notes to 12. And you can open those notes right now and have them below your workbook to 12. So that when we are ready to proceed, you're not like, oh, I didn't have my notes out yet. And so just open them each day, like to the notes on 12. Okay? So, number 3, that negative exponent. First off, when you're doing negative exponents on your calculator, you need to make sure you understand how to put that in. So 9.4, some of you, depending on what you're using for the power key on your calculator, it might be a caret key like this. It might be a y to the x key like this, right? And then you're going to put in 3, and some of you have to put the negative first. Some of you will type a 3 in your calculator, and then you'll hit that plus minus button. Or, after you put the 3, you'll have a button that has this kind of a parenthesis with a minus. But you should try it right now and see that you get 0.001239. They just rounded it. They put, yeah, it's on 5. They have it 2 right? Is it 1239? Is that right? 12039. That's where it's on. 12039. So that answer is okay. So 12039 is what you should have had. Okay. So 1.0239. When you put in 9.4 to the negative 3. Okay? So at this point, you have this really small number. So when I was looking at number 3, we had 0.012039 times 10, and we were taking 5 times negative 3, right? Is that what it was? 5 times negative 3. So when we multiply 5 and negative 3, power to a power, we are multiplying. We get negative 15. This number is not in scientific notation. But just to be clear, this was telling us, this times 10 to the negative 15. What this negative 15 told you is that you should move this decimal over 15 more places, right? That's what the negative 15 means. So we want to place it to be 1.20, and then it says round to the thousandth, so 20, we're not going to use 3, we're going to put a 4. It is going to be, this was 15 places, this is going to make it 16, and Maddie, our answer should be? Negative 18. So 15, we're moving it 6, oh, I should have one more 0 here. 16, 17, 18, negative 18. Answers were in the back as you were looking at those. Yes. You don't have negative exponents when we work with variables, but in scientific notation, that just tells us it's a really super small number. So we are going to have it with scientific. But if you were just doing an exponent problem, like x to the negative, like 3x to the negative 4, and I ask you to simplify that, then yes, definitely, I want you to do this. But scientific notation, we keep it negative. So let's do number 4. We're going to take 8 to what power? 8 to the 3rd times 10, and we're taking negative 2 to the 3rd. 8 to the 3rd is a pretty big number. Ben, what'd you have? 512. Times 10 to the negative 6. Emily, 512, the decimal's way over here in scientific notation. I'm going to write it as what? 5.12. This was telling me move it 6 places. Now I need to only move it how many places? So let's think about it this way, because if you were getting confused on that, I heard 8, which was not right. This is telling us we had to move it over 6 places. I don't have to move it as many places now, right? This is 5, this is 4. 5.12 times 10 to the negative 4 power. Someone said, oh, so it kind of matters if this is a big number or if the exponents are negative. Yeah, you can't just like always add a number or subtract. You gotta be careful. And think about, what does this exponent tell you, okay? So answers were in the back. You should have yours completed. I would like you right now to just turn in your notes to 12. Now, as you're doing that, I just want to show you on the daily planner. There's 2 videos in this. So the video explaining real world problems, and then this is another one. These are the 2 videos. I don't think I'm going to show them, but it's like a different math teacher explaining how to do these real world problems. Yeah.
Can you check our homework? Can you check if it's right or not? Because I was really tired yesterday.
Oh, so turn to the back and correct it on your own. The answers are there. No, I am not going to correct those when the answers are back there. And you just have to turn to the back and look at them and like mark it right or wrong. I'm not going to. Where I'm going to see that is if I give you a homework quiz, right? And I ask you to do it. What's that? It's graded like on a completion grade, so I'm going to come walking around and see. But I'm not going to look, did you correct it? Because I'm hoping you did. So, just know that on the daily planner, some of you have been using that, some of you are not. I put everything there. You don't understand how to do these story problems, go back and watch some of the videos. Look at the notes. So, here's this problem, and this video is a video explaining it. We're not going to watch it. It's about 4 minutes long. The other one's like 11 minutes long, so we're definitely not going to watch those in class. But this one says a newborn baby has, if we're looking at that, how many cells? 26 million cells. So you're studying cells, 7th grade science right now. It says an adult has 1.9 times 10 to the 3 times as many cells as that newborn. Yeah.
Wouldn't it be 26 billion? Yeah.
26 billion, yes, thank you. So it says, how many cells does the adult have? So the first question we have to think about is, are we doing add, subtract, multiply, or divide? If I would have told you using simpler numbers, that an infant has 8 cells and an adult has 20 cells. And I say, well, how many cells? The adult has 20 times as many. What would you have done to solve that? You probably would have, Jack, multiplied. You probably would have taken the simpler problem, right? If we think of this, the simpler problem, you would have taken 8 times 20 and got your answer. But we can't use these simple numbers. So the first thing we're going to do is we're going to convert this number to scientific notation. So that 26 billion, that is 2.6 times 10 to the 3, 6, 9, 10th power. And the adult has 1.9, so this is a multiply problem, right? That's the first thing we want to think. And some of you, when you start reading these questions, and on the test, there's going to be 4 questions that are going to be story problems. And those probably are the ones that freak people out the most. They say, I can't do it. So just slow down and think. And put a simpler number in the case. Oh, think about if it would have been 8 and 20, what did you do? You multiply. So think of the simpler problem, and then now we're going to do that. We are going to put 2.6 times 10 to the 10th. And we are going to multiply that by 1.9 times 10 to the 3rd. Now, when we just did all those worksheets with multiplying, we took the coefficients 2.6 times 1.9. So yes, you need calculators. You're multiplying. When you walk in this classroom, you should always have your calculator with you. We are then taking 10 to the 10th, yes, grab one, times 10 to the 3rd. That means we are adding exponents. Thank you. Remember, when we multiply, we add exponents. Start bringing your own, okay? You guys need to have your own calculator. Okay? So if we are looking at that one, Multiply in your calculator. 2.6 times 1.9. Maddie, what'd you get?
49.4.
Wait, 2.6 times 1.9?
4.94.
You got 49 or 4 points? Go back. Put in 2.6. 1. Okay. 4.94 times 10 to the 13, right? Times 10 to the 13. Is our answer in scientific notation? Yes. The question said about how many cells does an adult have? We would say an adult has 4.94 times 10 to the 13 cells. Okay. So when you see that video as you're looking at it, so let's take a look at the next part. This is the population again. We're looking just at application problems. The population of North Dakota back in 2012 was 6.99 times 10 to the 5th. The population of Oaks is a small town, right? Outside of Fargo, kind of going towards Fargo and maybe Bismarck, Jamestown, I'm not exactly sure. Has a population of 1.84 times 10 to the 3rd. Is there many people in Oaks? Like 1,840 when they did this, right? Does that make sense? 1,000. Okay. About how many times greater is the population of North Dakota as the population of Oaks? How many times greater? This phrase right here, how many times greater, should be giving you a huge hint that you want to divide. Times greater is division. Okay? So the whole reason we practice all those exponent rules and our adding, subtracting, multiplying is because it's all about the real world problems. I don't care if you can do it all by itself. You need to be able to do it in this situation. So this is telling us North Dakota as to the population of Oaks. So we are taking North Dakota and dividing it by the population of Oaks. We are taking 6.99 times 10 to the 5th divided by 1.84 times 10 to the 3rd. I need someone soon to volunteer that's going to be my reader for the next one. When we do that on your calculator, you are taking 6.99 and dividing it by 1.84. Abby, what'd you get? 3.7, one more place value, that's it. 3.79 times 10. What are we doing with our exponents? 5 minus 3. Now, you're taking the test and you don't show 5 minus 3 and you put down 8 instead of 2. I can't give you any points, right? This might be a 4 or 5 point question on the test. And you leave your answer as 3.79 and then you put times 10 and you don't put second and you forget and you add these two and you tell me 8. And you don't show this, that's like an automatic 2 points off. It's going to be 2 points kind of for this part and 2 points for this. So the question is about how many times as great is the population of North Dakota than Oaks? We want to write it out this way. We want to say the population of North Dakota is about 379 times greater than the city of Oaks. Does that make sense why I changed it maybe to standard form? If I'm talking about how many times bigger and I'm trying to explain it maybe in a newspaper article or someplace else, if I put this down, a lot of my general public isn't understanding 3.79, which is unfortunate. But they should, because they should have had it in 8th grade math. But they might not understand scientific. So the paper is going to put about 379. They might have even put it's about 400 times greater, right? Because they might even estimate 379 to be 400. Okay? All right, let's go to the next story problem. the mass of Jupiter is big. And the mass of Mercury is huge too, but it's quite a bit smaller, right? What is the combined mass of both? Combined mass means we should add. So we want to add. What do we do when we add? We go big, right?
Go big.
Go big or go home. We're going to go big. So we are going to write the 1.8986 times 10 to the 27. My second one has to be 10 to the 27. So this was 23 places. That means I'm going to have 23 moving it over 23. So this would be 24, 25, 26, 27. Okay? So when I'm thinking about that, I had to move it. This was 23, 24, 25, 26, 27. Okay? So I want to write that number, and I'm adding these. So I have 0, and I should have 1 in front of that. After that, 3. After that 3, I should have 1, 2, 3 zeros. Does that sound right?
Yeah.
So 23, because I had the 3. 1, 2, 3 zeros. I want to line up my place values. Then I'm going to have 3, 0, 2, 2. And I'm adding these. What's my combined mass?
63302.
3, 3. Oh, thank you. Yep. 3,
Oh, yeah.
3. Yep, good. Good thing you guys are adding up here. So we're adding these with these different zeros times 10 to the 27. And if I ask you to write their combined mass and I say round it to the nearest thousandths, if I'm rounding this to the thousandths place, I'm really talking about 1.898. Did it even matter that I added these together?
No.
Not really. It was so small. My answer is 1. And yes, you could add these 1.89, and this would have been a 9, and then 3, and then I don't want anything that ugly on the test. I want you to round it and tell me 1.89 or 1.899 maybe times 10 to the 27. Okay? Let's look at that next one. Okay, is that making sense when we think about these? Okay? So, the key thing with all the stuff that we've been doing this whole unit, exponent rules, scientific notation, everything we've been doing is to lead you to real world problems and how can you solve them using what we know. So, I need someone to read. Any volunteers? Gavin, you're on. Whitney, you can take the next one and then we'll keep moving through. Okay, go.
A light year is equal to 9.5 times 10 to the 12 kilometers. The Andromeda galaxy is approximately 2,300,000 light years away. How far is that in kilometers? Write your answers in scientific notation. You must explain your work.
How ugly is that one, right? What are we even doing if we are looking at this? So 1 light year is that many kilometers, and it is that many light years away. Anyone have an idea what they think we should be doing? What do you think? Subtraction? Subtraction. No. Definitely not. Kylie? Multiplication. 1 multiplied.
Because your light year, and then if it's telling us how many light years away it is, if it's telling us how far a light year is, and then it tells us how many light years it is away, they want the answer in kilometers.
So this is telling us that it's this many light years away. So exactly. Let's change this first to scientific notation. So right behind the problem. You might want to do yours. There's probably a little more room to do it down below. That 2,300,000 is going to be 2.3 times 10 to the 6. We are taking 9.5 times 10 to the 12. That's how many kilometers we had. And it has to go that many. Remember when we did that, looking at how far away it was with the the planets, and then we zoomed in and zoomed out. So if you want to look at that video again, it's on the daily planner. Daily planner. Take a look. We're going to multiply 9.5 times 2.3. As I multiply that, Jessica, what'd you get? 21.85. Times 10, we're taking 12 plus 6. Darren, if I'm adding the 12 and 6, I'm going to have 10 to what power? 18. Oh, it's not in scientific notation. You leave this answer on the test. Next week, probably Tuesday or Wednesday, I got to mark it wrong. This is going to be 2.185 times 10 to the what power? Why 19? Moving at 18, gotta go one more, right? So to the 19. Okay? Questions? So, read on.
Data from a grasshopper count and infested field show that an estimated 2.4 times 10 to the power inhabitants. What is the density of a grasshopper population in grasshopper per acre? Why do you answer this?
This is kind of gross, but there's a question almost like this on the test. Study for test. There's a question like this on the test, okay? Make sure you take a look at this one and think about what we're asked. You're asked to find grasshoppers per acre. Per usually means division. So if you need to finish the notes, they'll be online, and then the video will be there too. Okay? So grasshoppers per acre as we look at that. And it says write your answer in standard form. Well, we're given this 2.4 times 10 to the 6 in 3 acres. That means we want to take 2.4 times 10 to the 6, and that, since it's per acre, you want to divide by the number of acres. Okay? So this is how many grasshoppers, right? Yeah. Does anyone know what an acre of land is? It's pretty big.
It's 57 men shorter by shorter times 7 miles.
What? Huh?
Yeah.
What did you say?
It's 57 men shorter by shorter times 7 miles.
What?
That's all right. That's okay. So we want to find out per 1 acre. That's what we're trying to find. Now, when I grew up, I was in a small town in Minnesota. We lived on a 1 acre. We lived out of town. We had a pretty big yard, right? So there aren't many 1 acre. My guess would be maybe if you live out at Riley's Acres, you could have an acre. If you live north of County Road 20, those ones aren't quite. But the ones way out, like in Highland Ranch, you might have an acre of land that you live on, okay? So kind of for you to think about if you know people that live in those areas. So 2.4 divided by 3. Do the division. Should be a decimal, right? What'd you get, Elena? 2.4 divided by 3. 0.8. And if you think of 24 divided by 3, right? We didn't have a 10 to the power, so that's going to be times 10 to the 6, right? Because this is really times 10 to the 0, right? That's what 3 is. So, they say write it in standard form. Should I put 6 zeros behind the 8? No, I should move it 6 places, right? So, this is 1 place, right? I get 8, that's 1. 2, 3, 4, 5, 6. How many grasshoppers are on that acre? 800,000 grasshoppers.
What
Yeah.
about the 0 in front? Yeah, it's not in science.
0 in front.
Yeah, it would be 8.
Yes. But this says
80,000.
you could have rewritten it as 8 times 10 to the 5th if I would have asked you to leave it in scientific.
Oh.
But it says write it out in standard. So it doesn't matter what it is since I just want to change it right to standard. Okay? Questions. Things you're not sure about as you look at this. Okay? Oh, look at this last one. There's another video I attached. Shaylee, you want to read?
Yes.
Go.
In April 2011, an online social networking site had approximately 200 million registered
And this is pretty old data, right? 2011? Keep going.
accounts. In August, the number of registered accounts had risen to 3.6 times 10 to the 8. How many more users were in August than in April?
And I was just listening this last week, and they were doing a thing on 60 Minutes on the people that follow. Do any of you guys follow some of the people that like advertise their products through like their little videos and all that kind of stuff? And so the social media has like exploded even way more than this. First off, 200 million. What does that look like? Let's write it out in. First, let's write out 200 million right here. Let's write it out in standard form. Okay, so write that out in standard form, right? So that'd be 200,000. That would be 200 million. That's what it looks like. Which means what? 2 times 10 to the 8. Okay? That's how many users were using this social network. Okay? It says it has risen to this amount. How many more? Subtraction. We are subtracting. Now, when we subtract, we have to use go big. So, which one should we be subtracting? Which one is our first one? 3.62. And this one, how nice is that? They're the same. Minus 2, that's really 2.0 times 10 to the 8. 1.62. Should it be 10 to the 16th or 10 to the 0? Or 10 to the 8? 10 to the 16, 10 to the 8, 10 to the 0.
10 to the 8.
No.
Should it be 10 to the 0 because we're subtracting? Are we subtracting or we're not? You keep this part because this is telling us this number, right? You can't make it that many times larger. That'd be a huge number, right? And you cannot subtract the exponents because then you'd only be talking about 1.62 more. That doesn't make sense, right? It did not increase by 1.62 users. It increased by, this is going to be what? 162 million users? That's what it increased by? Okay. Now, we're going to, I think, not look at this one, but again, this one should be if we read through it. Just read through and think, what are you doing? What should we be doing with this question? Should we be adding, subtracting, multiply, divide? Just write it by it, tell your shoulder partner, and then what are we doing for the last one? Okay? So, what should you be doing? Read it and check with your shoulder partner and see if you agree. Maria, what'd you guys decide? Combine, what are you doing? Add. If we are looking at Grace at that second one, what'd you guys decide for how many times is great? What are we doing? Did you guys decide back there, the two of you? Now you're talking, sure. What are we doing? We are not multiplying. We're dividing. Which one should I put first when I divide? Earth to the moon, right? So we have to put Earth's, whatever that information was for Earth up here, and we have to divide that by the moon. That's what it's telling us. So when you think of that, if you want to think of it this way, Earth divided by Moon, I don't care, that means division also, or like that, okay? Now, I want you to notice how terribly long 12 is. Turn in your workbook. It is not one page.
It's like 7
It is not 2 pages.
It is
not 3 pages.
That's too much for one day.
I know, I agree. So, next week, so,
Is that gonna be our homework?
so, listen. So, first off, what you need to have done for tomorrow, okay? Because this is on the back of your worksheet from today, and we are handing that in tomorrow when you walk in. You're going to cut this page out. So you need to have this page done because it's on the back of the power to a power. You need to have 1 through 10 done, okay? The first ones are comparing. The next ones you're telling me the greater. You have a multiplication, division. Some of these are pretty easy. Like it says, which of the following is not a way of writing 16 million? Well, there's probably only going to be one of them that is not the way of writing this 16,700,000, right? If you look at that second page, and I think on the daily planner, I tell you that we're going to cross off number 12. What did I put down? Skip 12, 23, 25. Let's cross those ones off for sure. 12, cross off. That is just not one or even, there's nothing on the test like that, so cross off 12. Number 23, there is not one anything like the test on that. 23. Yep. Or like 25. Okay. Now, by the time we take our test, which is next week, either Tuesday or Wednesday, you need to have the rest of 12 done. Okay? Does that mean that we are going to be doing that? You have tonight, you can do more of that. I just need the first page done for tonight. Okay?
Just up to 10?
Up through 10. But if you finish that, like right now you have 9 minutes that you're working and you start now on it, and you're working on this and you get it, keep going. Do more of it, right? Because the more you have practiced, my guess is the better you're going to do on the test. Okay? The more you have practiced these things, the better you're going to do. Okay? And if you have questions, I would love to help you out.